Welcome to Algebra 1, Lesson 11, Line of Best Fit. The first task will be a which one doesn't belong. The second will be a 3-act task about a boy's height. And the last will be a Desmos activity, Line of Best Fit. Let's start with a graspable math whiteboard. So on the slides, the first slide tells them to click here and you will follow the instructions in the whiteboard. They have options. They can draw and they can type text. They can insert a text box and type in it. They can also type over the text in the text box that are already here if they want to. But they do need to indicate which one doesn't belong and why. So they could say something like, well, only the first equation has an X on the left side of the equal sign. And the last equation doesn't have any negatives at all in it. Things like that, and they may come up with some other ideas, so don't limit it to that, but any reason that they can look at that equation and say it's different, then that's fine. That's a good answer. And then finally, down here in the left corner, it says to manipulate these equations and answer this question. Are all these lines the same line? Are they different lines? Are they a combination of lines? Well, if you distribute your 2 on this one and you click here, you can combine them. And you'll notice this one is identical to that one, so at least 2 of them are the same. If they take this y and they add it to the other side of the equation, and then they can tap here to combine and get rid of the y and minus y, they can add 1 to both sides of the equation. And you'll notice this is equivalent to this. And if you put this y on top, like that, it'll switch sides, and you can see that these are also identical. To distribute, you take this 2 and put it inside, and then take this 5 and add it, and then you would simplify. And you'll see that all 4 equations, if you put them in slope-intercept form, are identical. Now, I would not show them that, especially initially. We want them to get an opportunity to play with the software and to just see. You can't break it, and if they mess it all up and they want to start over, they can go back and get that original link and do that. I do want to show you a couple of things. If they want to move this around, then they can use this arrange tool, and these turn into little cards that can be moved around. So if they want to move it around, that's how you do it. And then to get back to the way it was, click on transform, and now everything's in place. If they were doing this, if they left it here, they would still need to indicate which one doesn't belong and tell me why they chose it, explain your thinking using either a text box, and then they'll take a picture of their work and they're just going to insert it on their slide. So they would just paste a picture here. Now the next activity is about a boy. His name is Braden. His name is not mentioned in this slide, but you could tell them if you want. And it does have this, it is mentioned in the picture. So if you click on the picture, it's going to take them out into a full screen mode, and then they can zoom in to the picture and look at it closely and read the name Braden, and they see these numbers. And so their goal on this first slide, this is Act 1, is to come up with 1 question and 2 things that they notice. So leave it up to them to notice whatever they notice and have them include that. And then maybe from the class you can solicit questions to move this task along. Now I'm going to give you this link in your teacher notes. This is the actual 3-act task. And there's the picture that you just saw. And then it tells you Braden celebrates his 6th birthday this May. Well, we now know that's in 2014. And every year we mark his height on the shed door frame. So before you leave Act 1, you would give them that information. Make sure they know Braden celebrated his 6th birthday in May, and that would be in 2014. And every year they mark his height. So questions you have when you look at this picture. So they have some text here that you can read, and you can read some of this to your kids. These are some questions that we hope they'll ask. So your goal is to solicit questions, and he explains, the person that did this explains how they solicit questions from kids. And they're trying to get them to ask one of these questions so that we can quantify that and actually create an equation and analyze it. And here's the question that he wants to explore. They want to know how many years it will take for him to reach at least 6 feet tall so that he can play basketball. Or at least he thinks he has to be 6 feet tall to play basketball. So that was the question he wanted to explore, but you could, of course, choose one of these other questions. Now, once they've done Act 1, here's where you will step in, and you will have to give them this data. You could print it out and give them a copy. You could give one copy to each team so they could share. Or you could just display it and let them get it. But here it is, his age, 6, height, all that's in here. And then your goal is to have them use that data to create a scatter plot, a linear regression equation, and then use that equation to estimate the answers to their questions. So Act 3 is where they're actually using the Desmos calculator to create an equation and then analyzing their data with the equation. Now, on the slide, it says you will be given data by your teacher. So this is where you'll step in and give them that data, however you want to give it to them, and then they will use that data to then create a table, a graph, and an equation. Now, this is the first time all I've given them is a bare link. I mean, it's just the calculator. There's nothing in here. I've done no work at all for them. So they will have to add a table. Some of them will know where this is, and some of them won't. So you may need to, circulate the room and make sure they know where to find their table if they've not put one in before. And then over here, they should know how to fix their graph settings and to label the X and label the Y. And they should also know how to do a linear regression equation, because this will be, I think, the 3rd or 4th time that we've encountered this. So hopefully more and more kids are starting to remember. And some won't. That's normal. So we'll keep reminding them. But we do want them to get to the point where they will automatically know, oh, I need an equation, y1 tilde mx1 plus b, and it will give them the equation. Then they'll go back to their slide. They do need to paste a copy of the graph, the table, the equation, and they need to answer the question. So here it says make a prediction to answer the question. So whatever they have for their equation, they will use that equation to make that prediction. And that's important that you point that out if they don't catch it. You don't just pick a number randomly. You actually use the data that you have been given and use the equation that you have created to answer this question. And then once they've typed here, they'll need to type on this slide. They will need a picture of their graph, table, and equation. So screenshot it or export it or both. And that's the end of your slides. So the last task is going to be a Desmos activity. And this is a line of best fit activity. So there's only 8 slides. I really like this one though because it actually shows them how residuals work. It also shows them what it means for a line to be a line of best fit. How is that determined? Because we haven't really talked about that. So on the first slide, they're going to put a line through this data, and they're going to choose one of these purple points for their line. So the line should intersect one of those. Which one would be the best choice? And then on this one, you're going to make a prediction based on your line. Where do you think your line will be? How high do you think it will be when your X value is 100? And then on this one, they will actually physically move their line down by sliding it into place wherever they think it goes. So they may think it goes here. They may think it's a little flatter. So it's totally up to them at this point. There are no wrong answers. They just have to make sure every kid does that. And then be sure to read your teacher moves because they do give some pointers down here. Now, once they get their equations here, they're going to copy this into this blank and change this X to the 100 to actually calculate the value using the line they created. And then on the next screen, it's going to give you some residuals. Remember, the residuals are the distance away from the black line. So this is very close to the black line, but under it. So this should be close to the x-axis. And then on this one, this is where they get to learn what a residual is, and what the whole point of a line of best fit is. You will square these numbers in this blank, and you can actually do it right in the blank. They tell you to put it in parentheses, but technically only the negative numbers need to be in parentheses. So they can use parentheses or not on the positives, but they definitely want to square negatives in parentheses. And it will actually do it in the blank, so they can just type it here. So if you move this around, what's going to happen on this screen is that number is going to change. And it doesn't have to be 11 or 12. It could be even 9 or 8. Oh, there's a 9. And so your goal is to get the kids to drag this around and see how small they can get that number. The smaller, the better. Residuals measure error, and if you're squaring the residual, you're just making sure that if it's a negative error, you're getting a positive number. That's why they square them. And the sum of those give you this number. And when this number is small, your line fits really well. And when this number is large, your line does not fit well at all. And that's the whole activity, basically. So it's kind of fun. The kids would be able to use this in their portfolio, because technically when they place this line, it's very unlikely they're going to get exactly the same line as another person. It's almost impossible. So almost every kid will have something unique, which means it's a good artifact for the portfolio. So that concludes this lesson. This one is definitely shorter than most of your lessons. Probably you can do it in one class period, depending on how much time it takes you to finish your 3-act task and how in depth you'd like to go with that. If you have any questions or comments, as always, find me on Twitter, and y'all have a great day.